So this is us finally starting to build up an instruction code for our CPU, which is really the start of our assembly language. It's a long video this, but it's worthwhile going through it in some detail. Also, if you get stuck, it's worthwhile again downloading the file from the resources section and messing about with it yourself to see how it all holds together. So good luck with the video. If you look down in the resources section, you'll see a file called ALU Instruction, so you can go ahead and open that up and then head down to CPU and you'll get this CPU design opened. So let's go and have a look at that in a bit more detail. So in this video we're going to use an actual instruction which we're going to place in the instruction register, and this instruction will go and act on the control unit, and it's going to do something simple. What we're going to do is we're going to put a number in this register here and a number in this register. We're going to add both the numbers together and the final answer will be in this register here. So let's have a quick look inside the control section. Now don't get too worried because we're going to talk our way through it, but this is the first part where we're actually building some logic into the control section. So this is the control section here that we'll have whenever we've finished this video. So there's a bit involved in it, so we'll take our time and go through it, and you can always at the end open this up and have a play with it yourself and try it out and see exactly how it's going to work. So we can see here that we're actually going to be putting an instruction in here, and this instruction is going to allow us to add those two numbers and put the number in to one of the registers. But before we do that, let's go ahead and we'll start looking at our instruction set. So don't worry if this is looking a bit confusing, it'll all become apparent as we work our way through it. So let's start looking at the instruction set. Now whenever we looked at adding two numbers, and also when we did the fetch cycle, those weren't actually part of our instruction set. Those were hardwired, and we hardwired them just to give us a lead in to show us the direction we were going to take to build up the control section. So actually from now on in, we're actually going to look at the instruction set here, which is going to control the logic which we're going to build up inside the control unit. So don't worry if you don't understand everything that's happening here on this page, because we're going to take the information that we have here and we're going to build it physically inside the control unit. So what we have here is 8 bits, and this 8 bits goes into our control unit and it controls all of the logic which we've still to build, which switches all of the sets and enables. So first of all we're going to look at something called the ALU instruction. So whenever the most significant bit here goes high, then we know we're going to be using an ALU instruction. If that's the case, then the next 3 bits we see here are going to refer to the functions within inside the ALU. So for example, if the next 3 bits were 0, 0, 0, we know that would be an add function within the ALU, and we've got our shift right, left, the not, the and, the or, the XOR and the comparator. Now we also have 4 bits left over, so these 2 bits here, those refer to our 4 registers. So we can have a register R0, R1, R2 and R3. So those are our physical registers that we've got built in the CPU. Now what we do is we group these together and we call them Reg A. But remember, Reg A is not a physical register, it just refers to the grouping of these 4 registers which is controlled by these 2 bits in the instruction set. Similarly, we can look at the 2 least significant bits, and again these refer to the 4 registers R0 to R3, and we call that register B, And again, register B is not a physical register, it just refers to the grouping of these 4 registers, which is referred to by the 2 least significant bits. So it's a bit of a mouthful there in that page, and granted, if you've not seen this before, you maybe be scratching your head. But let's go and we'll take this and we'll go and build it in Logisim, and it'll all become clear. So let's stay in this level for the moment without getting into the control section. Now what we want to do is we're going to put a number into this register here. So I've disconnected the input here, and we're just manually going to input a number into this register. We're going to manually input a number into this register. We'll add both of them together, and the answer will be held in this register here. So we're going to actually physically put in our ALU instruction. So our ALU instruction is going to be 1 for the most significant bit. So when that's as most significant bit is high, we know we're in an ALU instruction. So the next 3 bits refer to the function that we choose within the ALU. So a 000 is the add function. Now the next 2 bits here refer to our reg A, and the next 2 bits here refer to our reg B. But remember, reg A just refers to the 4 registers here, and the reg B, again, it just refers to the 4 registers there as well. So what we want to do is we want to add the 2 numbers together. So this register here is going to be given by our 01. So that's going to be our register 2. So it goes register 012. And this register here is going to be our register 3. Okay, so it goes 0, 1, 2 and 3. Now, so this is telling us that we're going to add these two, the contents of these 2 registers together. Now we need to actually put something physically in these registers, so let's put a value of 4 in there, and let's put a value of 3 in there. So now we're all set up in order to add these 2 numbers together and put it in this register. So we can get into the control section now and have a look and see how this is actually wired. Now, as I mentioned before, there's a lot in this video, so we'll just take our time and work through it, and if you get stuck, you can always open this file up and you can just play with it yourself to get an understanding. So let's go in and have a look. This is us inside our control unit, and you can see there's a lot involved in this, but we'll take our time and work our way through it. So we're going to split it into little chunks. So the first chunks we're going to deal with are these reg A and reg B and the outputs to our registers. So you can see that we've got our instruction set coming in here, and of course it's split into the 8 bits, and we've got the most significant bit is a value of 1, which tells us it's an ALU instruction. The next 3 bits tells us that it's going to be an add, and the 10 tells us that we're referring to reg A, and we're referring to the register number 2 from reg A, and we're referring to register number 3 from reg B for these 2. So let's follow the 2 least significant bits up. So these 2 bits are coming up here, and you can see they get in here to this thing here called reg B. Now remember, reg B is not an actual register, it just refers to the accumulation of the 4 registers here, so the R0, 1, 2 and 3. Okay, so it's just a grouping of these registers. So when this goes in here, it goes into A and B. Now this thing here is just a 2 by 4 decoder, so it takes the 2 inputs here and it produces our 4 outputs. So really just it chooses a particular value here. So for example, this is 1, 1, so that should be register 3. So whenever the 2 before decoder comes out, you see it's picking this line here, and you can see it's getting into this AND gate. So ignore the AND gate for the moment. You see it passes through here and goes into this point here. So this is into this OR gate. So it's trying to choose this register 3. Okay. Now it can't actually choose the register 3. There's 2 things has to happen. One, the clock has to go high, which it is at the moment. But there's another thing has to happen before it's able to choose that register. And you can see here that there's actually a connection here if we take it out here, and it goes up to this thing called Reg B. So that there is just another part of the circuit. So somewhere else within this control circuit is determining whether we actually allow the circuit, the control unit, to choose this register 3. So similarly, we can look at these two bits here, and you can see that these two bits here, this is them heading up there, and you can see there's a 1 and there's a 0, and this goes into our Reg A, and again it's a 2x4 decoder, so it takes the two inputs and gives us our 4 possible outputs. And you can see here we're actually choosing 1, 0, which is a number 2, so that goes register 0, 1 and 2. So it's coming down here again into this AND gate here, and it's trying to choose this value here, register 2. But again, it won't choose it unless the clock enable goes high, which it is at the moment. But also, what also will have to happen is that our register A will have to be chosen here from this input line, and that gets chosen from some other part of the circuit. So some other part of the circuit will actually control, and it will tell us whether you can actually get access to that register, but we'll see that just in a minute where that other part of the circuit is. So you'll also note that the two least significant bits here, which get into this Reg B, they also go off to the right and they get into another 2x4 decoder. Now this 2x4 decoder, it goes in and it controls the sets for our registers. So that's the register 0 set, 1, 2 and 3 set there. Now they won't actually go high unless the clock set has gone high, and also there's one other control point here, and it's some other point of the circuit called Reg B underscore set. So this here will control whether we actually get a high on the set. Okay, and remember these things here are just tunnels, so it just saves us from drawing the wire from one point to another. Okay, you can actually see this is actually this point further up here, but we'll get to that just in a minute. So finally, in this little section down here, which covers almost half of what we want to cover, you can see here that we've actually got the opcodes for the ALU. So this is choosing which function we want to use within the ALU. Now we've seen here before that we have this value 1, so whenever the most significant bit goes high, then you can see this as goes to a value of 1, and this 1 goes into each of these AND gates. And then there's 0, 0, 0, well that could be anything, so we've got 8 possible combinations of these 3, and these go into the AND gate as well. But there is one other point as well that also controls whether we actually give the opcode out or not, and you'll see that it's further up here, so we'll see that in a minute. But ostensibly these 3 bits here will come out and it will choose the opcode. So these here head out and then of the control section, and they go straight into the ALU. Okay, so we've come quite far. So now for the second part of our journey into this control section. We mentioned before that nothing's going to happen at these outputs here for our registers or our ALU or our sets here for these registers until these other points here go high. So for instance, this Reg A enable goes high, or the Reg B enable goes high, or Reg B set goes high. And as I mentioned before, these are just a different part of the circuit. So all this is just a tunnel, and it just saves us from actually drawing the wire from this point up to another point. So for example, this Reg B set is actually that point there, Reg B set, and they're the same point. We just don't want to put the wire up, it just makes it cluttered. So where do these come from and what controls these? Well, let's look at one as an example. We know that whenever we put a 1 in there, it's an ALU instruction. So if we follow the line up here, we'll see it goes to 3 AND gates. So we're getting at that one, and that one. So let's take this first AND gate for example. The other input to this AND gate goes to the stepper. So there won't be anything happening until this stepper has stepped through and got to 1, 2, 3 and got to position 4. So when the stepper's got to position 4, this AND gate's going to go high. It means the output's going to go high and something's going to happen. Okay, so nothing will happen until we choose the ALU instruction and the stepper gets to this point. In which case this goes high, and it's going to do two things. So first of all, it's going to make this point reg B enable high, and it's going to make the temp set high. So all this does is it just chooses an enable from this side and a set from this side. So previously these would just go down and be hardwired straight on, but that's no longer happening. We're actually choosing it via our instruction code at the bottom of the screen, at the bottom here. So it's getting chosen from our actual instruction. So if we were to follow this reg B enable, so the reg B enable is now gone high, so there's the reg B enable there. So the reg B enable has gone high, and we follow that down, then these are going to be high all the way down here, and you can see at this point here, this point is now gone high, our clock has gone high, our clock enables high, and also we've got our choice here from our instruction set which is also gone high. So whenever this clock pulses along to that point there, it means that this AND gate here is therefore going to go high, and we're going to choose this R3. So the value of R3 there is going to be enabled onto the bus. So we'll pick our value for R3 and it will go onto the bus. And also, once that's happened, we'll take that value and we'll set it in the temp register. So those are the only two things that happen at step 4. But whenever the stepper moves on to step 5, the same process occurs. We have an ALU instruction, get into this AND gate, the stepper goes high. When the stepper goes high, we get an output now on this line. And in this line here, it's going to make reg A enable high, and it's going to make the accumulator set high. Equally, whenever we've done point 5 and the stepper's moved on to position 6, it's then going to ensure that this AND gate will go high. So when this comes down here, this AND gate will go high, and we're now on this line. And on this line, we enable the accumulator, and we also enable the set value, or return the set value high in reg B. So you can see this process here of the stepper working through and these lines here then being enacted. So let's actually see this simulation running. So if we go to the top level, now we're going to simulate it, so make sure the simulation's turned on, so simulation's enabled. Now we're going to count through our clock pulses here, so nothing will happen until we get to clock pulse 12. Okay, so we know that it takes 4 clock pulses to get through each, so it's going to take our clock pulses, and we'll, at that clock pulse 12 we'll actually get to the stepper number 4. Okay, so if you just count these through, 1, 2, 3, 4, 5, 6, and on the 12th clock pulse the enable goes high, and we've got to stepper point number 4, and we know it's an ALU instruction, so that's gone high. Stepper point number 4 has gone high. We've got an output here, and we can see that the reg B enable's gone high and the temp set here has gone high. So if we come down here to the reg B enable, so that's the reg B enable, it's gone high, so it means that this AND gate here can now go high, and we can see that we've chosen register 3 from reg B, and you can see here that's just what we're asked to do in the instruction code here, which is the 1 1 here. Also, we can see here that the temp set has gone high. So if you come down here to find the temp set, that's the temp set there. Now it hasn't actually gone high yet. It won't go high until it actually gets the clock pulse from the clock set. So it will get that clock pulse whenever we get into the next pulse along. So you can see how fine the detail we can get here with this clock. It's because of the fact that it's a 4-cycle clock, and we can get every single set and enable change within the CPU. So well, it's gone high there, and you can see here if I come back inside now that the temp set will go high. So that's the temp set gone high here. So we've got our Reg 3 enable, so we take the information from the contents of Reg 3, we put it onto the bus, and then we copy that into, or we set it in or write it in to the temp set. So in the top level you'll see that, if you look at it, you'll see here that we've read out the information here on this register here, which is the value 1, 2, 3. So you can see the two top lines, the two least significant bits have gone high here, which is this value here. We put it onto the bus, and we've also set the temp. So we're taking this information here from this register and we're sticking it into the temp register. So let's continue to the next part. Okay, so that's everything that we need to do in this line. So there's only two things done there. So whenever the stepper goes to 0.5, we're going to have another couple of things happening. So Reg A is going to be enabled and the accumulator is going to be set. So let's go ahead and we'll set this up. So we're looking for the next clock pulse, enable going high. So that's our enable gone high, and you can see here and there that enable's gone high there, and it's put the value 1, 2, 4 onto the bus, and that value will just come along and it will drop down into the ALU here. Now we can also see it's set the accumulator. So let's go down, we'll see the accumulator. So there's accumulator down here. Now it will actually set the accumulator whenever the set clock pulse comes along here. Okay, so let's just go along, we'll get to the next clock pulse, and that's gone set, and it's set the accumulator. So what's happened here is we've got the two values now sitting in A and B. So we've got a value of 4 there, a value of 3 there. So we can also go in and have a look at the opcode here for the ALU. So it should be have chosen the add opcode in order to add both of these together. So if we go down to the control section, you see this 0.5, you see it's coming all the way down here, and it comes all the way down here, and it's now gone into these AND gates. So the AND gates have gone high, and the value for the ALU instruction has gone high, so that's 1 there as well. So it means that the value here, the 000, will pass straight through these AND gates. Okay, so if I change these to any particular value, these 3 bits, they'll now appear at this output here. So we also have our opcode all set up. So now we're ready to go on to our final part here, which is part 6. So we'll go up to the top level and we'll pulse it again until our clock enable goes high. So that's our clock enable gone high now. And let's have a look and see what it's done in the control section. So the clock enable has gone high here, and we've got an ALU instruction, and there's one other section here which comes from a compare instruction, but we'll talk about that later on, so there's no need to bother about this bit here just right now. So this has gone high, so it means that we've got two other things happen. The accumulator is enabled, so the value of the sum of the two, the 4 and the 3, which is 7, is in the accumulator, and we've stuck that value onto the bus. So the accumulator has been enabled, and then the Reg B has been set. So let's have a look and see the accumulator first of all. So the accumulator has been enabled, so the value that was in the accumulator was the sum here, which is 7, so you've got 1, 2, 4, which is 7, so we've placed that 7 onto the bus. So the very last thing that we're going to do, if we come down here, you'll see is that Reg B has now been set. So the Reg B set here, well, this is a Reg B set here, and it controls the set. Okay, so it means that we're going to place the value into register 3 whenever the clock set goes high. So when we go into the top level and we do one more clock pulse, we'll have the clock set would go high. Now obviously I've actually just connected these, but the clock set would be high here. You can see the pin just going high. But of course we wouldn't actually see the value going into the register here because we had already disconnected the register in order to start off the whole process. But you can see that the final value here is 7, and if this was now connected here, this 7 would be placed in this register. So well done if you managed to get this far. There was an awful lot in this video. If we get into the control section, remember what we started off with was just hardwiring into our sets and our enables. But now we've got an instruction set here, and this instruction set now controls what's happening here within the control unit. So we can imagine taking this instruction set, and rather than having ones and zeros, we can start using a bit of mnemonics, and we can start giving our instructions names. So this really is the start of our assembly code. But you'll get to understand that a lot better as we start building up new instructions over the next few videos. So that's all there is for this video. Thank you for listening, and goodbye.